So we're doing section 10.4 right now. It's called one-way analysis of variance test. Probably this is going to be the easiest test, guys, that you've ever seen. You will see how easy this test is, but it's very important as well. Let's say, guys, there are 4 places that people can go on vacation to. And the 4 places are owned by the same company, like 4 different, just hotel chains. And you want to figure out if the average cost of vacationing in the locations is the same, no matter which location you choose. So you have the average cost in location 1, the average cost in location 2, 3, and 4, and you want to check if the average is pretty much the same if you go to any of the 4 locations, or whether it's not the same. So here we're talking about not 1 mean only or 2 means, we're talking about 4 means. Remember in chapter 8, guys, you were able to figure out whether 2 means are equal or not equal. mu1 and mu2, you compare 2 means. But when it comes to comparing more than 2 means, 3 or more, 3 or 4 or 5 or 6 or 7, all of the tools that you learned in chapter 8 will not be sufficient, for this. So if you want to compare whether 3 means are equal or not equal, you have to use a distribution called ANOVA. It's an F distribution, which I'm going to show you how this F distribution looks like, but we're just going to use technology. It's going to be 100% driven by technology. And this distribution, the test that we're going to perform, it's called one-way analysis of variance test. It's called ANOVA. And this is the very last test under tests on your calculator. So this ANOVA is used to determine whether there are any statistically significant difference between the means of 3 or more independent samples, independent groups. 2 means you use chapter 8. More than 2 means you use this test, which is called ANOVA. So what I provided in this handout, just in steps and how to use this test. And the good news about this one, guys, the null hypothesis and the alternative hypothesis are always the same. So let me show you here. The one-way ANOVA compares the means between the groups you are interested in and determines whether any of those means are statistically different from each other. So here's how you state the null. If I give you 4 groups, guys, in the exercise, you put HO mu1 equals mu2 equals mu3 equals mu4. That's the null hypothesis. So you assume all the means are equal. If I give you 5 groups, you put mu1 equals mu2 equals mu3 equals mu4 equals mu5. If I give you 3 groups, you go up to mu3, but you cannot do less than 3, because less than 3, you're back in chapter 8. 1 and 2, you're back in chapter 8. HA, guys, you need to memorize this. At least one of those means is different from the others. That's that statement that you always have to write as your null and the alternative. So that does not change. That does not change at all. So is the statement in HO. Okay, so let me show you the distribution that we're going to be using just to have a visual of it, guys, but you're just going to use the calculator and not worry about the details of the distribution. So you learned the Z distribution, you learned the T distribution, you learned the chi-square distribution. I promise this is the last one. It's called the F distribution. And the F distribution is used to check if 3 or more means are equal or not. That's the F distribution that we're going to be using. Okay. The F distribution is a family of curves, which let me show you that family of curves right here. The value of F is always positive. Look, guys, it starts at 0, no negative values. It looks like it is skewed to the right. It has 2 degrees of freedom. One is called the numerator and one is called denominator. And you notice as the degrees of freedom of numerator and denominator become close to 30, this distribution will have the shape of a bell shape curve as the numbers go up. So this is the F distribution. Total area under the F distribution is always equal to 1. All the values of F are greater than or equal to 0. As you notice, we start at 0 here. So we're always on the positive side right here. Okay. So that is the F distribution. And the distribution, the F distribution, guys, is skewed toward the right. So it's not symmetric. It's always skewed. It's just like the chi distribution. The difference between the chi distribution and this distribution, the chi distribution has only 1 degrees of freedom. Here you have 2 degrees of freedom, one for the numerator and one for the denominator. So this is what the F distribution is. Any question about this before I do an exercise and show you how to perform this test? You're going to find it very easy test to perform. You will see that in a second. We'll resume recording here. Okay. Assumptions of the test. Once I ask you to perform the test, guys, you don't need to verify the assumption, but this is what we usually check for. Each sample must be randomly selected. Must be randomly selected from a normal population. All population must be normal, guys, in this course. Bell-shaped or approximately normal population. So this is number 1. Number 2, the samples must be independent of each other. And there is one condition, one more condition for the test. Each population must have the same variance. If he just asks you to perform the test, guys, you don't check them. You assume that these are assumptions, that we have to make an assumption that they're true in order for us to perform the test. So these are the conditions of the test. And let me just take you to an example right away. I would appreciate it if you have your calculator ready, guys, and just show you how to perform this test. So we're going to begin with the first example on here. Example 5. Watch. A medical researcher wishes to try 3 different techniques to lower cholesterol levels of patients with high cholesterol levels. The subjects are randomly selected and assigned to one of 3 groups. Once you see, guys, more than 2 lists, right away you should suspect it's this section 10.4 because it has more than 2 groups. Group 1 is given medication, Group 2 is given an exercise program, and Group 3 is assigned a diet program. At the end of 6 weeks, each subject's cholesterol level is recorded. Test the hypothesis that there is no difference among the means. When he says test the hypothesis that there is no difference, that means test the hypothesis that they are the same. So here's how you start, guys. HO mu1 equals mu2 equals mu3. HA, just like I stated earlier, at least one of the means is different from the others. Okay, can you guys tell me where the claim is? Is it an HO or HA? test the hypothesis that there is no difference amongst the mean.
HO.
Yep. No difference means equal. If I say there is no difference between what you get paid and I get paid, that means we get paid equally. Okay, so that's step number 1, guys. Step 2, test the statistic, which is F. Step 3, p-value. Step 4, reject or fail to reject HO, the same steps. And let me show you how to do this exercise. So we're going to bring the calculator back and clear. We're going to go to stat, edit, and you guys, you have to enter the lists into your calculator. You have no choice but doing this. Clear, enter. Okay, let's enter them. L1, what do I have for L1? I have 11. I'm trying to use this calculator so you guys can see the keystrokes, how I'm doing everything. 12, 13, 15, 9, and 8. Then you go to the next one. 8, 3, 5, 2, 4, 0. Okay, group 3, and we'll be done there. 4, 12, 4. Do you guys think that the 3 groups are the same? It looks like one is different from the other 2. Can you guys tell which one? It has different values than the other 2. Which one do you think, guys, has more different values?
Group 1.
Yeah, it looks like the values are larger. We'll see. So probably they're not the same. Probably we're going to reject the null hypothesis. Okay, ready? Here's how you run the test. You go to stat, tests, scroll up. You see the last one is ANOVA. That's the last test. Click on it. What do you think I should enter here, guys? Common sense. It's waiting. The cursor is waiting for us to enter something. What does the calculator know? I need to know here. Any guess?
How many categories?
Yeah, you need to enter, tell the calculator where the categories are. You have 3 different groups, so put L1, second and number 1, comma, second and number 2, comma, and second and number 3. Told you guys it's not a difficult test. Done, that's it. And enter. And here you go. The first value is the test statistic, it's F, and the second one is the p-value. Don't worry about the rest, guys. So F is, so how do you run the test? So you go ANOVA, L1, L2, L3. So you get F equals 11.09. It's 2 decimal places. And the p-value, guys, is 0.0011. Alpha is 0.05, so that's less than alpha. Reject HO. You see, I told you we're going to reject the null hypothesis because they're not the same. They don't look like they are the same. There is enough evidence at the 0.05 level of significance to reject the medical researchers claim that there is no difference among the means. You notice there was a difference. It looks like the results in group 1 are much larger than the other results. And that concludes this question, guys. So this is what analysis of variance test is. It's called ANOVA, and that's how you perform the test. We're going to do definitely some more examples, of course, but that's the first one. Okay, let's do another exercise. So let me just. So a researcher wishes to determine whether there is a difference in the average age of middle school, high school, and college teachers. Teachers are randomly selected. So you want to check if the age of a teacher, whether he or she is a middle school, high school, or college teacher, is the same. Teachers are randomly selected. So that's condition number 1. And they are independent because they come from different schools. So the conditions of the test are met. Their ages are recorded below. Test the hypothesis that there is a difference in the average age of each group. So here's how you start, guys. HO. Let me just remove that calculator for now. Mu1 stands for middle school, Mu2 for high school, and Mu3 for college. HA, at least one of the means is different from the others. All right, guys. And where is the claim now? Can you tell me where the claim is? Is it in the null or the alternative?
Alternative.
Yeah, there is a difference. No difference, guys. Take a note here. No difference means the claim in HO. Difference means it is in HA. Exactly. Okay, let's run ANOVA. ANOVA L1, comma L2, comma L3. You have to go to stat, and then tests, and then this one, ANOVA. Okay, let's bring it back, bring the calculator back, and I'm ready. So stat, tests, scroll up. ANOVA stands for one-way analysis of variance. AN analysis, O of variance, VR. Okay, so L1, second and number 1, comma, second and number 2, comma, second and number 3, close parentheses, and we're good to go. Enter. There you go. You get the F. Step number 2, which is if you round it to 2 places, to a 5.52. And the p-value, guys, is 0.1142. Which is, of course, bigger than alpha. Yeah, I thought that they were very much the same. So we were going to fail to reject HO, fail to reject HO. And you start, there is not. Why? Because we failed. There is not enough evidence at the 0.01 level of significance to support the claim that there is a difference, or to conclude. To support the claim or to conclude, if you want to use the word conclude here, that there is a difference in the average age of each group. Any questions, guys, here? That's how we perform the test in this question. Days spent at the hospital. In a recent study, a health insurance company investigated the number of days patients stayed at the hospital. In part of the study, the company selected a sample of patients from 4 regions, so they're independent samples of the United States, and recorded the number of days each patient spent at the hospital. The table shows the results of the study at alpha equals 1%. Can the company reject the claim? Once they say, if they're asking you to reject the claim, that means they want you to test if they are equal, because that's what the null hypothesis is. That the mean number of days patients spent at the hospital is the same for all 4 regions. And you can see the data, guys, they're not exactly the same. You see here, there is more here than there, so that's fine. And we're gonna need 4 lists, L1, L2, L3, and L4. So we put the data in L1, L2, L3, L4. L1 stands for Northeast, L2 Midwest, L3 South and West. And he wants to check, can the company reject the claim that the mean number of days patients spent at the hospital is the same for all 4 regions? So the claim is mu1 equals mu2 equals mu3 equals mu4. And alpha here, guys, is at 0.01. So I don't need this anymore. And let's do the exercise. So that was section 10.4, number 12. And I don't remember the page. I'll pick it up in a little bit and put it, I'll put it in there. So HO, mu1 equals mu2 equals mu3 equals mu4, and that's what the claim is. HA, guys, as I told you, it's the same statement. At least I would memorize this. One of the means is different from the others. It doesn't tell us which means if we support HA, but at least we know that one of them is different from the others. Okay, and now we're gonna go to stat, and we're gonna go to tests, and we're gonna run ANOVA, and we're gonna put L1, L2, L3, L4. I don't think you will have problems with more than 4 lists in this section, probably 1. So now you go to stat, calc, sorry, not calc, tests, scroll up, point up ANOVA, and let's enter the values. Second and number 1, comma, second and number 2, comma, second and number 3, guys, comma, second and number 4, and then close parentheses, press enter, and here you go. So what's F? 0.56. P-value. You can see how important this p-value is by now. 0.6478, which is definitely bigger than alpha, guys. And fail to reject HO. And final step, there is not enough evidence at the 0.05 level of significance to reject the claim that the mean stay, mean stay, it's a number of days. Just copy and paste the claim from the book. Number of days stay at the hospital is the same for all 4 regions. We are saying here probably the number of days that the patient can stay at the hospital is pretty much the same. Whether you are in the west, east, northeast, southeast, it doesn't matter. It is pretty much the same.